So let's get crack-a-lackin' here. We're going to be doing the snowflake still, remember, but this time we're going to be solving. So our first move is to make sure that everything is on one side and set equal to 0. And then we also have to make sure that they're in descending order. So that means highest power to the lowest power. So if I look at problem number 1, I need to rewrite this as m squared minus 10m minus 24 equals 0. It's got to be in descending order. If it's not, flip it around, move it to the right order. Otherwise, when you try to set up your snowflake, you're going to have things in the wrong spot. Once I have it in order, descending order, everything on one side, then I'm just going to use the snowflake method that we've done before. Remember, if I don't see a number in front, it's 1. So that's 1 times negative 24 is negative 24. Middle number is negative 10. This is 1m and 1m. I don't need to write them both. I just write m and m. And, I don't need to write the 1 in front is what I'm saying. And then I'm looking for two numbers that when I multiply them, I get negative 24. When I add them, I get negative 10. What'd you say? 6 and 4 will, if I do positive 6 and positive 4, I won't get negative 24. If I make one of them negative, which I would need, I'm going to end up with a difference of either negative 2 or positive 2. So 6 and 4 is an obvious answer that doesn't work here. What's another option besides 6 and 4? Remember, you can start by doing like 1 and 24, 2 and 12, 3 and 8, 2 and 12 looks like the one that works. Yep. So this would be positive 2 and negative 12. And then when you get here, you're going to set those parentheses up, but without the parentheses. You're going to set up two little mini equations. My first parenthesis would have been m plus 2. So I do m plus 2 equals 0. The next one is m minus 12. I do m minus 12 equals 0. And then I solve. M equals negative 2, subtract 2 on both sides. M equals positive 12, add 12 on both sides. That becomes my final answer. So it's just one added step. Instead of writing them in the parentheses, you're going to solve and set them equal. So we'll go through that process on problem number 2. Problem number 2 is in perfectly good order. That's the way it needs to be. It needs to have everything on one side and in descending order. Second power, first power, no power. And then once we have that set up, again, you can do your snowflake. So this is negative 15 on the top, positive 2 on the bottom, 1v and 1v, I can just write as v. And then I come up with my two numbers that when I multiply, I get negative 15. When I add 5 and 3, one of them has to be negative. Which one? Negative 3. Great. So again, when I set this up, v plus 5 equals 0. V minus 3 equals 0. And then solve. Just basic, these are basic solving equations, like the lowest level of equation that we've solved, which you don't really have to show a whole lot of work. At this point, you're probably pretty good at it, most of you. When you see answers to these problems in multiple choice, they put them in those little bracket things, and they usually write it as like two numbers next to each other. So when you do multiple choice, which you will, this will be the way they write the answer. But for us, we can just write it like the v equals and the v equals. So the last two are problems that aren't equal to 0, and I just kind of want to go through that process of getting them equal to 0. You're going to do a little solving as well. It's the opposite sign of what is here, so this is negative 18. I want to bring that over to the other side by adding 18, but I can't add it to anything. There's no like terms over there, so I'm just going to write this in descending order. Plus 9n plus 18 equals 0. So I just bring the 18 over. It's just honestly like changing the sign. If this were positive 18, I'd write it as minus 18. But then once I get everything on one side, it's got to be equal to 0, because we're using something called the zero product property. So that's why we have to have everything equal to 0, so we can set the factors equal to 0. The top would be 18, bottom is 9, 1n and 1n. Two numbers that multiply to be 18 and add to be 9. What's that? Yeah, it looks like 6 and 3 will work. Both positive, because the top is positive and the bottom is positive, so they're both going to be positive. So I'll write this as n plus 6 equals 0, n plus 3 equals 0, n is negative 6, n is negative 3. Again, if you're doing a multiple choice, it would write them as negative 6 comma negative 3. Almost looks like a point, but it has the squiggly things on the outside. And then the last example that I wanted to go through is a problem like number 4, where it's the middle term is on the other side, but I still bring it over the same way. It's just that when I set this up, I'm going to minus 12n on both sides, minus 12n. This would be n squared minus 12n minus 35 equals 0. I put it in the middle because that's the first power term. And I kept these guys pretty nice. I tried to do all that the front number was 1, but we'll practice more when the front number's not 1 to see how that looks, but just for starters. So my top is negative 35, my bottom is negative 12, 1n and 1n. Two numbers that multiply to be negative 35 and add to be negative 12. Ooh, this is a bad problem. I don't think that's going to work. Let's make this plus 35 here. Just change that to a plus, because it's negative 7 and negative 5. And it won't work unless they're both negative. I just made a bad problem. So we'll change it to plus and all will be well. So this is n minus 7 equals 0, n minus 5 equals 0. And then solve the little mini equations. So it's really the same thing you've been doing, just one added step.